Morro de amor pelas águas da ria. Esta espuma de dor eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor nesta rede que teço, e é no sal do suor que eu aconteço.
A terra, o ar, a água encontram-se na ria salgada pelo mar, embalados pelas marés e misturados pelo saber dos marnotos, alquimistas do sal. Como o cristal branco é a pedra basilar e angular de Aveiro, o ensino, a cooperação e a investigação e inovação são os pilares da academia. A Universidade de Aveiro cresceu e transbordou para a região, para o país, para o mundo. A interdisciplinariedade é também uma marca distintiva da Universidade de Aveiro, em que cientistas de todas as áreas partilham e crescem em conjunto, em campi que promovem os encontros e com eles mais e melhor futuro. Inovadora, pioneira na transferência de conhecimento, a Universidade de Aveiro, com as suas 90 nacionalidades, é ponto de encontro de gentes do mundo, de culturas, de línguas, de amores e de paixões cosmopolitas. Uma torre de Babel, mas que mantém uma linguagem única e não desmorona. E sempre o sal, porque esta é a Universidade de Aveiro, a Universidade das pessoas, alquimistas da água, da terra, do ar.
O António diz que você tem gente que saiu, mas foi andar para vocês para o Eu acho que a minha solução é a gente começa e pedimos ao António que fosse ao dado. não é aqui.
It's not necessary. People should. We have Firelinks. Yes, it's inside the building. Wait for us.
Morro de amor pelas águas da ria. Esta espuma de dor, eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor nesta rede que teço, e é no sal do suor que eu aconteço.
A terra, o ar, a água encontram-se na ria salgada pelo mar, embalados pelas marés e misturados pelo saber dos marenotos, alquimistas do sal. Como o cristal branco é a pedra basilar e angular de Aveiro, o ensino, a cooperação e a investigação e inovação são os pilares da academia. A Universidade de Aveiro cresceu e transbordou para a região, para o país, para o mundo. A interdisciplinariedade é também uma marca distintiva da Universidade de Aveiro, em que cientistas de todas as áreas partilham e crescem em conjunto, em campi que promovem os encontros e com eles mais e melhor futuro. Inovadora, pioneira na transferência de conhecimento, a Universidade de Aveiro, com as suas 90 nacionalidades, é ponto de encontro de gentes do mundo, de culturas, de línguas, de amores e de paixões cosmopolitas. Uma torre de Babel, mas que mantém uma linguagem única e não desmorona. E sempre o sal, porque esta é a Universidade de Aveiro, a Universidade das pessoas, alquimistas da água, da terra, do ar.
Morro de amor pelas águas da ria. Esta espuma de dor, eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor nesta rede que teço, e é no sal do suor que eu aconteço.
Air, water, they come together in the sea-salted lagoon, rocked by the tides and mixed by skilled miners, alchemists of salt. Just as the white crystal is the pillar and cornerstone of Aveiro, teaching, cooperation and innovation are the pillars of its academy. The University of Aveiro surged and flooded into the region, the country, and the world. Interdisciplinary research is also the foundation of the University of Aveiro, in which scientists from many fields share and grow on a campus that brings people together, forming a better future. The University of Aveiro, an innovative pioneer of knowledge sharing with its 90 nationalities, is a gathering point of people from all over the world, a space of different cultures, languages, and worldwide passions. A Tower of Babel, but one that retains a unique language and does not collapse. And always the salt, because this is the University of Aveiro, the University of the people, alchemists of water, earth, and air. Earth, air, water, they come together in the sea-salted lagoon, rocked by the tides and mixed by skilled miners, alchemists of salt. Teaching, cooperation and innovation are the pillars of its academy. The University of Aveiro surged and flooded into the region, the country, and the world, in which scientists from many fields share and grow on a campus that brings people together, forming a better future. The University of Aveiro, an innovative pioneer of knowledge sharing with its 90 nationalities, is a gathering point of people from all over the world, a space of different cultures, languages, and worldwide passions. A Tower of Babel, but one that retains a unique language and does not collapse. And always the salt, because this is the University of Aveiro, the University of the people, alchemists of water, earth, and air.
Okay, start. Okay, good afternoon everybody. We should start our lovely session with a half an hour late, but that's okay, we have time today. I'm sorry, first of all, I'm sorry for the cold room. The physics department director asked some apologies because the room was closed for changing the chairs and painting during some time, and that's why it has this look. But it has a good size, and the university is fully occupied today. We couldn't change it on the last minute, okay? So we should start our session. I want to thank all of you for being here. This is very important. We will have this public session between two blocks. Session 1, Fire Impacts on Soils, Water and Biota, and Session 2, Managing Hydrological Fire Impacts. On Session 1, we will have a presentation from João Pedro Nunes from the University of Lisbon, Jonai from Swansea, and Nelson Abrantes from the University of Aveiro. The expertise of these researchers will go through the subject of our session, that is fire impacts in water. After that, we will have a roundtable discussion, and then we can make a small break and we go outside for our coffee break, and then we go back for the second session, okay? I should also say that this session is being streamed on YouTube. Who has my Twitter account, they can share it. It's on Twitter right now, and will be recorded in the university website, so you can check it afterwards if you want to see more details about the presentations of every researcher. Okay, so I'll give the word to João Pedro Nunes. You have 15 minutes. And maybe if we have time, we can make some questions. Huh? Okay. So thank you. João, please.
Okay, I need to put my glasses on as I cannot see. Good, so, welcome, thank you Diana for the introduction, thank you for coming, those who are not part of our COST meeting. I am João Pedro Nunes, as Diana said, from Sciences, University of Lisbon, although I work here for 5 years, so I'm half Aveiro University as well, at least with a legacy. I'm going to show you some work that has been done in conjunction with the School of Agriculture of the University of Lisbon, with Águas de Portugal, which is a water supply company, and with the University of Aveiro itself, including Diana there. And so, since my presentation is the first, I thought I would give you an overview so others would not have to give you an overview, yeah? So, in fire-prone regions like central and northern Portugal, water resources often come from forested watersheds, so they burn, and fires create an ash layer which may contaminate downstream water resources. So I will give a very short overview of the problem for those of you that have no idea of what I'm talking about. Maybe everybody does, we'll see. A framework, I will present a framework on how to assess those fire contamination risks, and then I will speak a little bit about Project Frisco, which is a recently approved project to manage fire-induced risks of water contamination. So to start with the fire disturbance. So the main thing here is that fire disturbance leads to a loss of vegetation cover. It creates an ash layer and it changes soil properties. The ash layer has low density. It is highly mobile. It can stay suspended in water a long time, the ashes at least. It is associated with contaminants such as polycyclical aromatic hydrocarbons, metals, nutrients, etc. And the creation of this ash layer is combined with the hydrological impact of fires, such as enhanced runoff and enhanced erosion. And there is a time between the fire and the period when things are recovered, and during this period is when we have opportunities for water contamination, assuming that it rains. So in a nutshell, this is the thing. It's a very short thing. So I have a video, and this video, if it works. This is a video from the University of. You want me to put it lower?
I will do something.
Yeah, okay. So, this is a video from the University of Aveiro, from the people here who work on post-fire contamination to their surface processes team, where I used to work, where Diana works, etc. And, yeah, nice. And this illustrates very well the problem with the mobilization of ashes in a burnt area. So you can see that they are, a lot of them have low density, they are easy to mobilize. The water becomes turbid with them. You have a lot of ashes reaching the water lines after an episode. And I wanted to say that this is after the 2017 fires. I think it was taken a few weeks after the 2017 fires in the summer storm. And you can see the kind of impact that this kind of stream contamination can have. But don't think that we are the only ones with this problem. So yeah, we have the issue in 2017. They have this issue in the UK in 2011 with the Belfast fires. It's somewhere unexpected. It's a recurrent issue in Canada, North America. It happened in Australia, and we got contacted recently because of the bushfires in Melbourne, because they are really worried that this might happen again. I'm not even sure if it happened, if it has already happened again, contamination of water resources there after the fires that they had in Australia. So this is a global issue and a recurrent issue for people who are managing water supplies in fire-exposed systems. So, what kind of contaminants we are worried with? Well, it depends. Depends on what do you define water contamination as and what is your problem. So, for instance, from the perspective of water supply managers, turbidity can be a first concern because it can overwhelm the water supply system. But if you have a big wastewater treatment plant, or if you have a lot of dissolution capacity, then it ceases to become such a big problem. Toxic elements could be a bigger problem for aquatic ecosystem health than for water supply managers, because water supply managers can treat the water and remove them, depends on the amount that you have, but you cannot do this for aquatic ecosystems. Nutrients by themselves might not have a very big effect, but if they accumulate in a water body, they can lead to nutrient enrichment and eutrophication, often for years afterwards. And when you have eutrophication, then you have water quality and water treatment problems downstream. So, the contaminants that you are concerned depend on your problem. The problem you have also depends on the water supply system which you are managing. I think a good rule of thumb is the bigger the water supply system, the more difficult it is to be affected. And I give you an example for the 2017 fires. Those who were today in the morning session saw Marta speaking about this issue, that the fire affected this river and this reservoir. This reservoir is the water supply. This is the Alger River, which supplies the municipality of Ancião. In Ancião, they take water directly from the stream. They have a small treatment plant of 13,000 customers, and they had at least two long water supply interruptions after the 2017 fire, one immediately after, one in the following winter after rainfall. This because of ashes concentration in the stream. But just downstream below, the Lisbon water supply, which has a large reservoir of 900 million cubic meters, a large treatment plant which serves about 3 million customers, there were no interruptions of water supply, most likely because of the dilution capacity, but also because of the installed treatment capacity could be able to handle this, while smaller systems would not. So, water contamination, my point was that water contamination, contaminants of concern depend on which problem you are facing. If it is an ecosystem contamination problem, if it is a water supply problem, if your system is large enough, or if you have a small system for a mountain village. Now, given all of this, we have passed, I think, the last 3 years trying to compile the opinion of people to try to direct us on whether our research should go. So we published a paper, a commentary paper in 2018 with a lot of international experts where we try to systematize knowledge. John is going to speak after. He was also involved in this. Just after, we had a workshop funded by the Cost Foundation and by the Placar project in Lisbon, where we brought these experts to Lisbon and also people from the water supply industry to discuss this and to try to find out what are the research priorities, what do we need to learn next. And with the result of this, we published a policy brief, which is online if you want to see, which had some influence with the European Commission in setting up this H2020 Horizon Call for Forest Fires, because then Project Placar is an H2020 project. They have links with the European Commission and they can bring this stuff to a level which we scientists alone cannot. And we continue this effort. Like in January, we were in Paris with the OECD, with a high-level meeting where we discussed this with insurance companies, with the ambassador of Australia to the European Union. So we are trying to promote this, and this meeting today and this workshop that we are having in Aveiro is part of an ongoing effort to bring together scientists and at some level the managing people, so you can help guide us towards what we should be doing. Just want to say that this is funded by a cost action called Firelinks, which is trying to organize fire research in Europe, but you will see something after this at the end of the session. So, what comes out from our systematization of knowledge? We call this a framework for progress, which tells us more or less how we should assess risk in our fire-prone catchments. And so we have two important moments. If you have a fire-prone catchment and you have a fire, the fire will generate contaminants of concern. But they will only contaminate a water asset if they are mobilized by hydrological and erosion processes. You have a number of options to fight this. I would say sometimes maybe from the most complex to the simplest. You can fight this at a structural level, so you can control your fuels, you can try to prevent fire from occurring, or you can try to prevent severe fires. Well, this is of course part of a fire control policy, of a wider fire control policy, but it's also important for water quality management. Then you can try to control it during fire suppression by protecting your key water assets. You can do it, I think, what is normally done after the fire by trying to mitigate erosion and making emergency stabilization measures to try to prevent these contaminants that are in the soil from reaching the water lines. And then the end of the line option is water treatment. So, how do you prioritize this? How do you prioritize these kind of actions that you can take? And you don't know which actions you can take because they depend on your system, and we show on this paper that they depend on the mobilization processes, on the part of the world you are in, on the river you have, on the water treatment system you have. So we identify three important things to design mitigation measures. First, we need to identify what are the contaminants that we are worried about. Is it turbidity? Is it nutrient enrichment? What are we worried about? We need to understand how they are mobilized and map the dominant pathways, so we can try to understand where should we act. Before the fire, after the fire, at the treatment level, what is the most effective option? I am focusing a lot on municipal and water supply for human use. Yes, this option is not available if you are concerned with ecosystem impacts. So, based on this approach, we just launched Project Frisco, and by just launch I mean it started a month and a half ago. So we had, after the 2017 fires, the Portuguese government decided to put money to try to address a number of pending issues. And so a lot of research projects were approved with a focus on practical application. So we were asked to submit research projects where we would have partners from the private sector and where the final result would be applicable, so they could not be theoretical research. And so we built a consortium between us, sciences at the University of Lisbon, where we understand about hydrological and erosion modeling and science policy interface. So we have a number of social sciences working with us. The other partner is Águas de Portugal, Waters of Portugal. So this is a company which is a holder for a number of companies which supply water throughout Portugal, where they understand about water supply management, of course. Then we have the School of Agriculture of the University of Lisbon, where they have a very strong group on fire analysis, behavior, and modeling. And finally, the University of Aveiro, where, as you will see, they have a very good group on post-fire hydrology and erosion. And so what we want to do with this project? So for the whole of the country, this is a bit ambitious, but we were asked to be ambitious. We want to analyze historical water quality databases for post-fire impacts. We want to relate them with environmental drivers such as fire extent, severity, contamination pathways, post-fire meteorology, and to combine this to calculate the post-fire risk assessment index, which will need to be online and which will need to be updated every year or every year after the fire season. Of course, there was a question this morning about what are the contaminants of concern for which we are going to do this index. Yeah, this is a good question. Excellent. So, at the same time, we will be working with 4 water supply systems at risk of post-fire contamination, one of which actually does not have post-fire contamination despite extensive fires. It's the one in the south, which is something we want to understand why. And we want to try to identify which contaminants concerned us or concerned water management there, which are the ones which the field may cause or may not cause problems, and assess the cost effectiveness of a number of mitigation solutions. So we want to try to compare pre-fire forest management with post-fire stabilization measures and with water treatment. Compare solutions, write this all on a manual which has to be ready by the end of 2023 or 2024, we don't know, let's hope. And so, in detail, what do we plan to achieve? What are we already doing? We are creating a national database of burn severity since at least 2000. But before we do this, we have to test satellite imagery against field data. This is where the University of Aveiro comes in. Oscar? This is where the University of Aveiro comes in. And so that we can have a national database of burn severity linked with a fire which occurred at a specific date. We want to map dominant transport pathways. Yeah, normally you need complicated erosion models for this. We are at the stage where we are trying to use these models on a number of study areas for which we have data and see if simpler approaches can do the job. Notably, hydrological connectivity index, and sediment connectivity indexes, which have shown good results in Galicia, I think. And yeah, we've been looking at your work. And also simplified annual scales models, which may be able to give us at least a good idea of where the pathways are. And assess past contamination events. So this is where the water management people come in, where we speak about analyzing past water quality data, speaking with the managers, try to understand what is the situations that concern them. And then in the second half of the project, we want to join this database, which will take some time to build, to create a water quality index. I say that statistically analysis, but what I mean is machine learning, I think, because I think this is the brute force approach that we have to use to get something out of all the data that we're going to collect. Implement it online. Fortunately, we have people with a lot of experience in the School of Agriculture, but this is the work also of sciences in University of Lisbon. And then how do we assess this how do we compare the different approaches? How do we compare the effectiveness of post-fire contamination management with pre-fire measures, etc. By linking a fire model with a hydrological model, and by running this model stochastically for thousands of times, and to get not only maps of probability of fire for these study areas, but also probability of contamination after a fire. Fortunately, this model is already built and already tested for the Alvares municipality in Portugal. Otherwise, this project would be very difficult to achieve. My final, yeah? So, what are we doing now? Compiling the fire severity history for Portugal, assessing it with field data. So this is the work of Agricultural Lisbon and Aveiro. Test the simplified methods to map contaminated pathways. This is the University of Lisbon. And we will meet with water managers. This is just a past photo, yeah. We will meet with water managers to discuss the post-fire contamination concerns. And so, you want to collaborate. You have our contacts here. You also have the policy brief that we wrote and which is still actual this time after. And otherwise, thank you for your attention.
We will leave the questions to the end. I'll call the next presenter. interesting presentation. Ah. You can use the pointer. It's the other way around. Okay. I spent the whole day saying this. Okay, please. Go ahead. Thank you.
Hola, my name is horário, as you know, and thanks to all of you for being here. I'm going to talk about a project. It's not that new. We've been working on that for the last 2 years, and our main aim is to develop an online tool for researchers and users to incorporate water contamination risk from wildland fire ash into the decision-making process. It's a joint project. It's led by the University of Swansea, but in collaboration with the Forest Service, the University of Idaho, and the University of Melbourne. And well, you're going to see a lot of pictures and figures similar to what Joao just showed you. So layout is different, and I'll try to give you a very short introduction on the topic. You know that most of the fresh water for human settlements come from fire-prone and fire-managed ecosystems like forests, like grasslands or peatlands, and also that during the fire season the reservoirs are highly vulnerable because of it's also the dry season. Usually the levels of water are often already low. You've seen something like this in Joao's presentation. The impact of fire affect the vegetation, affect the soil, can enhance erosion, runoff and erosion, and the material transported from the hills can end up in the reservoirs that provide fresh water to the human settlements. And one of the main problems after the fires is that we have a new contaminant source that it wasn't before, which is the wildfire ash. It's a mix of mineral and charred organic matter. We could discuss a lot about our definition, if it includes or not the mineral part, but this is our definition. It can be very thick, up to 10 centimeters, and can be rich also in potential pollutants like iron or nitrogen, phosphorus, and in some areas like the UK with a heavy past industrial activity, it can also have a mercury or a high concentration of lead. Joao also said that the density is very low, it's very mobile, it's also uncohesive, at least at the beginning, before the first rain event, so it moves very fast and very easy. And I'm going to show you some pictures about what happened in the past, in that interaction between fire and water resources. For example, the Canberra fire in 2003, the government spent $38 million in managing the drinking water treatment. The water was declared unfit for direct use for 12 months due to high turbidity and concentrations of iron, manganese, phosphorus, and nitrogen. You have an example here after, the Pedro Gal, sorry for the pronunciation, fire. And the main issue here was the presence of ash in the surface waters. And Joao talked about Australia this year. I don't know about Victoria, but in New South Wales they had this huge lake here, it's Burragoran Lake, that provides 85% of the water of Sydney, which is 4.5 million people, and it burned all around the catchment that drains to that lake. We don't know the impacts, we don't know the cost, but we are working with the local water supply company in those events. They also had last week the largest rainfall event in the last 30 years, so all together in just 1 month. Well, you might remember this graph here. I'm not going to talk about this. I'm just going to say that our main aim is to develop the online tool, again aimed at mainly at end users, that will predict the ash delivery and the contamination risk. So for you to understand, we will provide a probability of certain events or events of certain magnitude to happen. Let's say we know that the guideline value for lead in the water is whatever is a figure. The model will provide the probability of that level being exceeded. And it's built on an already developed and calibrated and validated for the US runoff erosion model, which is Web. And Web has this technology, the Web Cloud PET technology, which is already online, and you will see later. So, we identified 3 main challenges to reach our objective. The first one, we need to know how much ash is after the fire. And of course, we can go there, we can measure it, we can measure the depth or even the load, but for large fires, this could be very time-consuming and very, very costly. So we have developed a tool to estimate the ash loads using remote sensing images. It's a normalized wildfire ash index that has been already calibrated and validated for 2 eucalyptus forests in Australia, 1 coniferous forest in the US, and 1 coniferous forest in Spain. And we would be happy to calibrate it and validate it for other ecosystems. Second challenge, once we know what is out there, what is the load of ash in its spatial distribution, we need to know how it could be transported. So we've been using published data. You might be aware of this study here. It's a paper published by people from the CESAM, from the University of Aveiro. So they carried out a flume experiment with ash-covered soils with different ash types, let's say, and they obtained information on ash delivery. We used a tracer, and we converted the information on sediment delivery into information on ash delivery. And from that, we built our equations for ash transport. Those are the ones that are being used at the moment in the model. We also perform our own rainfall simulations to evaluate the impact of ash in runoff production, because it's ash is very light, but it also has a very high water retention capacity, so we can delay the runoff. So we built a proxy to predict the delay in runoff produced by ash, and we also perform those additional real simulations to improve our equations. In the future, in the near future, let's say, because the project will end next year, we want to calibrate that using field data. And we have been collecting sediment data from the UK, from the US, Australia, and Spain in this case. And we will try to calibrate it using that data. Again, we need a tracer to transform sediments into ash content. And we are working on that at the moment. I cannot tell you more about this. Well, we already know how much ash is out there. We kind of know how it moves downhill. We need to know now what's the potential contamination, what's the amount of contaminants that the ash contains. So we took samples from different ecosystems, again, Australia, United States, Spain, and the UK, and we've been carrying out total concentration of potential pollutants and concentrations of water extractable element in those samples. The total concentration would be for like a long-term impact, whereas the soluble elements would be for a short-term impact. And those are some of the results we've obtained so far. And well, this is the interface. As I said, it's open access. It's aimed at the users. It was already available for the US regarding runoff and erosion, and it has been calibrated and validated there. Now we have also implemented that new tool to predict ash delivery on the top of the runoff erosion model. And also we made available the interfaces for Europe and Australia. And going back to that fire I mentioned before, nearby Sydney, I'm going to use it as an example to show you how the model works. I'm not going to talk about a bit, I talked about a bit that already, so let's say I'm going to focus in this area here inside this frame. So the model will take the information from existing online databases, the information regarding topography, land use and management, soil properties, and climate information. From an end user perspective, this is great, because everything's there except a soil burn severity map. That's the only input that needs to be uploaded from the end user perspective. Everything else is already there. So what the model does is to delineate the channels and the subcatchments that drain to a point that we select, what we call the outlet. And each of those channels and subcatchments already have information on topography, land use, soil properties, and climate. And I'm going to jump now to the kind of results we will provide. There are 4 types of results we want to provide to the user. First one is related to the total delivery. As you can see here, we provide the probability and recurrence interval for certain episodes, but we also provide information on the ash delivery. This is in mass, in tons, and also, for example, for lead in kilograms, you have it here. We provide information on the worst case scenario, meaning all the ash on the hill slope going downhill and reaching the outlet, but also for certain events. For example, for 40% chances that we get 17 tons of ash in that point, or 0.1 kilograms of lead in that point we simulate. The second type of result would be related to the concentration. This is potential concentrations. Taking into account we don't know how the contaminant distributes in the watershed, but knowing the amount, the volume of the reservoir, we can calculate potential concentrations of contaminants, or even the ash for turbidity in case it's helpful. And the model takes into account the concentration, the current concentration of those elements in the reservoir. Fourth one would be the probability of concentrations of an element exceeding a guideline value. Again, we know the volume of the reservoir. We select the element, we provide the current concentration in the reservoir. Also the target concentration, let's say this is the guideline value, and the model will provide you a potential probability. Again, this is taking into account that we don't know exactly how it moves inside the reservoir. So that would be if everything is redistributed homogeneously. And the fourth type, it's a spatial distribution of the risk. So remember that figure here with all the subcatchments and channels. The model will provide information per channel and per subcatchments. So the managers could know which are the main sources of sediments or main sources of ash transported by water. So in the post-fires period, they can target those areas, they can prioritize the actions to prevent the ash from moving from this hill slope. And I don't know, do I have some time?
1 minute.
1 minute, okay. Yeah, very quick, very quick. I've been talking about real fires, but the model can be used also for simulated fires. Let's say we want to know what would happen if an area burns. That happened in the UK, for example. They were concerned about an area because of the past industrial activity. They realized that they have a lot of lead in the ash after the fire, blah, blah. So they told us to build a burn severity map. We use a fuel load, the fuel load in the area. We build the map and we run the model for that area. And we could go even further, and for example, we could test different fuel reduction treatments, build burn severity map for those treatments, and run the model and compare the outputs and select the treatment that reduce the risk according to what we need. Now I'm going to go back and say thank you for your attention.
Thank you, Janai. I'll now call researcher Nelson Abrantes from the University of Aveiro. What's this? Thank you, Nelson.
Okay, thank you for the invitation. Good afternoon. My name is Nelson. I'm from the University of Aveiro. And today my presentation is about the impacts of post-fire contamination on water quality. I'm working in Earth Surface Processes team. This is a team that has been coordinating several national and international projects related with wildfires. In fact, wildfires are our main topic of research, and based on on the results of past and ongoing projects, I will try to answer several questions. The first one, can wildfires be a diffuse source of contaminants? Okay, if we look at ash composition in terms of inorganic compounds, the main are magnesium, silica, potassium and calcium. Also in a lower extent we can find sodium, phosphorus and sulfur. And as trace elements we can also find some toxic elements. Regarding the organic components, ashes are mainly composed by PAHs and also by dioxins and furans. So, to try to answer this question, we look at mobilization of metals after a wildfire, and for that we select a barren area where we select different slopes, a slope in a eucalyptus plantation and other slope in pinus plantation, and we collect hash and also topsoil in different occasions, immediately after fire, 4, 8 and 15 months after the wildfire. So when we look at the metals contents in both hash and soil, the hash is in green, the soil in brown, we clearly see that for all the metals that we analyze, ashes present high concentrations compared to the soil. If we look at elements, manganese was element with the high concentrations. Besides the metals, we also analyze the PAHs in the same samples. And once again, comparing the ashes with the soil, we clearly see much higher concentrations, in this case the total PAHs, so we can clearly see that ashes present much higher concentrations compared to soil. In fact, PAHs, they are formed during incomplete combustion. So, as a second question, can wildfire impact water quality? So, after the wildfire, we have the ashes layer, we also have a topsoil that in terms of properties is completely different, and the ashes and also topsoil with the first rain, they can be easily eroded and they can enter into the aquatic systems, affecting the surface water by runoff, but also the groundwater by leaching. So, when the sediments and the ashes enter the aquatic system, what is expected? So, turbidity will increase. Also, the literature also reports an increase in temperature that is due to the removal of the riparian vegetation. Also, the depletion of the dissolved oxygen, and in opposite, there is an enrichment in nutrients, namely nitrogen, phosphorus and carbon, that will promote the eutrophication, and also an increase in metals and PAHs that can increase manifolds. Okay, in this slide I will show you some results that were published recently. So, we select a buried area where we install runoff plots that allow us to collect the runoff. So, we collect, in this case, we collect the runoff, we bring the runoff and we analyze nutrients. In this case, total nitrogen and total phosphorus. And we can see that with the first rain, in fact, we can find some peaks for both nutrients, nitrogen and phosphorus, and it's interesting to see that also in the second year of monitoring, we still find some peaks in these nutrients that of course are related with the ash and sediments that comes from the burned areas. I will show you also some results of an ongoing project, Firelinks, that is coordinated by my colleague, Dalila. She's there. So in this project, we look at two scales, at the slope scale and also at catchment scale. To study the impacts at slope scale, we install these what we call sediment fences that allow us to collect sediments, and we analyze the sediments in terms of PAHs and also in terms of metals. In the case of PAHs, the concentration were below the limit, the quantification limits, and respecting the metals, we found the main elements were iron, manganese, arsenium, and lead. These are preliminary results, not published. In terms of catchments, for the catchment scale, we select a stream, a main course in the burnt area, and we define 3 points, 3 study sites, downstream, upstream the burnt area, within the burnt area, and downstream the burnt area. And once again, we collect surface water, but also sediments, and we look at the concentration of PAHs and also metals. In the case of PAHs, once again, below the quantification limits. Also, metals. When we compare the 3 sites, the differences are not so evident. One explanation is because this area was affected by a low severity fire, so the canopy of the trees was not completely burned, and the leaves, they fall, and they function like a natural mulch, reducing the exportation of sediments. It's the reason that the contents of PAHs and also metals are not so expressive. Okay? So, as a third question, are the post-fire contamination toxic to aquatic organisms? So, if we look at metals and PAHs, we know that they are toxic, mutagenic, carcinogenic. They can also bioaccumulate through the food chain, and they can persist over time. In fact, they are considered priority pollutants. So, if they are adsorbed to the hashes, if the hashes can enter the aquatic systems, what happens when the hashes are in contact with the aquatic organisms? So, to answer this question, we ran several experiments. I will show you very briefly the results of some experiments that are already published. So, as a first experiment, we went to the field, we collect the runoff. You can see how it looks, this dark aspect, and we expose different species, aquatic species, to the runoff. Bacteria, Vibrio fischeri, also a microalgae, an aquatic plant, and a crustacean. And was interesting that the bacteria and also the producers, we found a toxic response. And this provides us the first evidences that post-fire contamination can be noxious to the aquatic species. So in the following work, instead of expose the organisms to the runoff, we bring hashes and we try to mimic the runoff, but creating what we call an ash extract. And we also found an inhibition in this case in a microalgae, and also inhibition in a macrophyta. We also test the runoff from, in this case, from an eucalyptus burn plantation, but also surface water from a burn catchment in a fish. But we use biochemical endpoints. Why? They are really interesting because they function as an early warning signals of exposure. So, in a low level of organization, we can find effects that for sure can indicate that at a high level of organization, we can also find that effects. So, we expose the fish. Of course, we always need to analyze our map piece. In this case, the stream water in green and also the runoff. And as we expected, due to the dilution effect, the stream in green present a much lower concentration of metals and also in terms of pHs compared to the runoff that are much more concentrated. When we expose the fish, in the case of the stream water, no oxidative damage was observed, but in the case of the runoff, yes, we found an oxidative damage, and this will result in cellular damage. So once again, we found that the exposition of the fish to the runoff is also toxic for this species. In another study, we also use a macroinvertebrate. Why macroinvertebrates? In fact, macroinvertebrates in terms of freshwater, they play a very important role. In terms of function, macroinvertebrates includes the detritivores and also the composer species, so they play an important role in aquatic systems. So the idea was to see how they react, how they respond when exposed also to runoff and also to the stream. So we exposed the macroinvertebrate, in this case a trichopter. This species is an insect that spends most of cycle life as a larvae, and it was interesting to see that once again we found a negative response also for the exposition to the runoff and also for stream water. Namely, if we compare, this is the control, so we clearly see a negative response. In this case, what we accessed was the feeding inhibition. So we expose the macroinvertebrates to the matrix, and then we offer leaves and we see the leaf mass loss. So once again, a toxic response. Okay, so to increase a bit the realism of our laboratory experiments, we also took the species to the field, and in this case, we defined 4 sites. This is our burn area. So we define one site upstream, the burn area, one site downstream, and 2 sites within the burn area. So what we expect is that ones are the most affected, but also downstream. So in this case, for the in situ, we have to build a specific chamber for each species, a total of 7 species. We also define different endpoints for each species and also a different duration of exposure. Okay. And usually during the rainfall events, when we expect an input of ashes and sediments to the stream. In this case, we just look at the metals, and it's interesting to see that for most of the metals, the highest concentrations were in the sites located within the orange, within the burn catchment, namely when we compare it with the reference, the upstream site. And when we look, I summarize all the responses of the species. When we look, and I'm just comparing the site upstream and the one of the streams within the burn area, and for most of the species, excluding the clam, that is really a tolerant species, was interesting to see again an inhibition in the response. You see, when we compare the upstream site with the stream site, okay, a clear response. So once again, toxic effects. Okay, just to finalize, let me talk a bit about some ongoing projects. One of them is Aquafire. In Aquafire, we are now using an integrated approach where we are using 3 lines of evidence: chemical, ecotoxicological, and ecological. And based on that 3 lines of evidence, the idea is to calculate the risks, not just for the aquatic ecosystem, but also for human health. In this project, human health is also a concern. And a second project that is coordinated by Dalila, and the idea of this project, at the end, the main goal is to have an ecotoxicological model that allows us to predict the risk of the PAHs and metal mixtures on aquatic species. So, as a concluding remarks, are the wildfires a source of diffuse pollution? Yes, they are an important source of pollution to aquatic systems, namely through the input of metals and PAHs. Are the wildfire, they can produce off-site impacts to the aquatic species? Yes, we found, looking at our experiments with different species, we found a toxic response. And despite our efforts to understand the off-site impacts of wildfires, we need to generate more information about this topic. So this still to be a challenging and very exciting topic to study. Okay, thank you.
Thank you. Thank you, Nelson. You can stay here. People can make some questions. You're going to run away. We decided, I know it's cold and chilly here. We are going just to discuss a little bit the subjects we talked about here, and then we can go to the coffee break, okay? So, I don't know if anyone of you already has questions to make. 1 question at least, 2 questions please. Okay, please, go ahead.
Hi everyone, I'm Katja. I'm a very unknown face to all of you. I'm from the biology department. I work in microbiology, and my question is going to be related with microbiology. My question, I understand that with the wildfires, the top layer is very affected microbiology-wise because there's a sterilization process going on. But there, as you said, there's going to be still some topsoil underneath that's going to have completely different, regular almost, conditions, and you'll still have active microorganisms.
It's a good question. I'm more focused on aquatic systems. It's my area of research. But from what I read, of course, there are impacts due to the temperature. For sure, the microbiome will change, but it's something that needs to be more explored and.
It depends on the degree of severity.
Yeah.
You can have almost no impact, but you can destroy all the microbiota. But it depends on the degree of heating of the degree.
Depends on the degree.
Yeah,
Yes.
on the fire, of course. And but still, there could be some that is impacted by the runoff effect, especially considering slope or something like that. And my question is regarding what happens after that. As a source of contamination, if we have ashes that are very rich on metals, for example, and from your data they are relatively rich, the bacteria that are already living in the water reservoirs that are receiving the ashes, they are a very complex community, of course. And this includes bacteria that have resistance to antibiotics, for example. And the molecular mechanisms that give this, allow this bacteria to be resistant are also resistance mechanisms that are related to metal resistance. So in a way, if the ashes are contributing with the source of metals, which is going to be an impactor for bacterial selection in the water reservoir, there could be a selection for antibiotic-resistant bacteria occurring in this whole scenario that I didn't see an account for in the projects.
I guess that is a really interesting topic to study. For sure.
Story is good.
From in Firetalks project, we collaborate with the University of Minho, where they look at bacterial communities in fresh water, the impacts of the runoffs or ash extracts in the bacterial, and we found effects. But in terms of community structure, not in terms of antibiotic resistance, but yeah, it's interesting, but we have no...
A side effect of
Agree.
introducing the metals
Yeah.
could be, especially if one of you, spoke about industrial areas being impacted with fires.
Yes.
And those are already going to be very rich in this type of resistances.
Okay.
And if they are the subject of the runoff, then that's a certain insert of more resistance into the water reservoir.
Okay,
Not
thank
sure
you.
anyone
No, that's a good.
We can discuss this a little bit more. I have another question here.
My name is Teresa Leitão. I'm from NEC, Portugal. And thank you for the presentation. It's very interesting. And this last debate was really very interesting. It can be something huge there. My question is, we have a lot of experience nowadays and results. And one of the issues that we are all the time worried when we think about water quality is what are the pollutants that are more interesting. And we have some good results shown by Nelson, for instance. And my question is, can we, with all the knowledge that we are getting, separate from different forests which are the contaminants that we are expecting? So after all your results, can we say, if I have a burned area with pine trees, this will be the elements, if it is oak, is this?
No. From our results, no. And why? Sometimes the forest is a mix.
Yeah.
And it's the result of this slope, that and that is exported. But even when we look at the runoff from just an eucalyptus slope or a pinus, the elements or the group of elements are mostly the same. The concentration can change if it's a pinus or an eucalyptus, but the elements are more or less the same.
So we are going to apply a black box, a brute force approach to this with machine learning. So will we be able to say this? Maybe, we don't know. But when you apply a machine learning approach, sometimes you are able to get the result and you don't understand exactly why you got the result. So maybe we will be generating more questions even for you if we manage to look at this only from a data perspective.
There are a lot of factors about that. I mean, it's not only the vegetation type, but again, industrial activity. There's a place in the States and they are concerned about the asbestos, because there's a mine there about that. So how could you predict that? Just knowing that that mine is there. So, I mean, it would be great from a vegetation perspective, you take into account severity, could be done, but we need to be a bit flexible and put all the variables together there. So.
But we need more knowledge. Of our ideas is to burn eucalyptus and also pines in the laboratory and see in different temperatures and see what is produced in terms of metals, pHs.
If they have a pattern, specific pattern.
Something also is the shrubs, the ashes that results from the shrubs, and shrubs are present on eucalyptus and also pines, and for sure contributes a lot for the hash mass.
It's interesting because in a project about forest fires, we have done that in our lab. We have a facility that is able to do that and burn. And in the end of the day, the ashes are not so different from completely different vegetation. Not only pine trees and oak, but also the subbush. So
Undergrowth.
the bush, yeah, the bush. And this is quite interesting in the
Okay,
sense
yes.
that probably the phenomena, as you were saying, which are industrial pollution and also the way the slopes and everything that happens after the fire within the watershed is controlling more than the origin of the ashes itself.
Okay, maybe we can stop a little bit and go for outside before we follow to the next group session. Okay, thank you all the presenters. We are only 15 minutes late. Yes, no, I know. The next presenters can give me the presentation, please.
Morro de amor pelas águas da ria. Esta espuma de dor, eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor pelas águas da ria. Esta espuma de dor, eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor nesta rede que teço, e é no sal do suor que eu aconteço.
Earth, air, water, they come together in the sea-salted lagoon, rocked by the tides and mixed by skilled miners, alchemists of salt. Just as the white crystal is the pillar and cornerstone of Aveiro, teaching, cooperation and innovation are the pillars of its academy. The University of Aveiro.
Morro de amor pelas águas da ria. Esta espuma de dor, eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor nesta rede que teço, e é no sal do suor que eu aconteço.
Earth, air, water, they come together in the sea-salted lagoon, rocked by the tides and mixed by skilled miners, alchemists of salt. Just as the white crystal is the pillar and cornerstone of Aveiro, teaching, cooperation and innovation are the pillars of its academy. The University of Aveiro, surged and flooded into the region, the country, and the world. Interdisciplinary research is also the foundation of the University of Aveiro, in which scientists from many fields share and grow on a campus that brings people together, forming a better future. The University of Aveiro, an innovative pioneer of knowledge sharing with its 90 nationalities, is a gathering point of people from all over the world, a space of different cultures, languages, and worldwide passions. A Tower of Babel, but one that retains a unique language and does not collapse. And always the salt, because this is the University of Aveiro, the University of the people, alchemists of water, earth, and air.
Morro de amor pelas águas da ria. Esta espuma de dor, eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor nesta rede que teço, e é no sal do suor que eu aconteço.
Air, water, they come together in the sea-salted lagoon, rocked by the tides and mixed by skilled miners, alchemists of salt. Just as the white crystal is the pillar and cornerstone of Aveiro, teaching, cooperation and innovation are the pillars of its academy. The University of Aveiro surged and flooded into the region, the country, and the world. Interdisciplinary research is also the foundation of the University of Aveiro, in which scientists from many fields share and grow on a campus that brings people together, forming a better future. The University of Aveiro, an innovative pioneer of knowledge sharing with its 90 nationalities, is a gathering point of people from all over the world, a space of different cultures, languages, and worldwide passions. A Tower of Babel, but one that retains a unique language and does not collapse. And always the salt, because this is the University of Aveiro, the University of the people, alchemists of water, earth, and air.
Morro de amor pelas águas da ria. Esta espuma de dor, eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor nesta rede que teço, e é no sal do suor que eu aconteço.
Air, water, they come together in the sea-salted lagoon, rocked by the tides and mixed by skilled miners, alchemists of salt. Just as the white crystal is the pillar and cornerstone of Aveiro, teaching, cooperation and innovation are the pillars of its academy. The University of Aveiro surged and flooded into the region, the country, and the world. Interdisciplinary research is also the foundation of the University of Aveiro, in which scientists from many fields share and grow on a campus that brings people together, forming a better future. The University of Aveiro, an innovative pioneer of knowledge sharing with its 90 nationalities, is a gathering point of people from all over the world, a space of different cultures, languages, and worldwide passions. A Tower of Babel, but one that retains a unique language and does not collapse. And always the salt, because this is the University of Aveiro, the University of the people, alchemists of water, earth, and air.
Morro de amor pelas águas da ria. Esta espuma de dor, eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor nesta rede que teço, e é no sal do suor que eu aconteço.
Air, water, they come together in the sea-salted lagoon, rocked by the tides and mixed by skilled miners, alchemists of salt. Just as the white crystal is the pillar and cornerstone of Aveiro, teaching, cooperation and innovation are the pillars of its academy. The University of Aveiro surged and flooded into the region, the country, and the world. Interdisciplinary research is also the foundation of the University of Aveiro, in which scientists from many fields share and grow on a campus that brings people together, forming a better future. The University of Aveiro, an innovative pioneer of knowledge sharing with its 90 nationalities, is a gathering point of people from all over the world, a space of different cultures, languages, and worldwide passions. A Tower of Babel, but one that retains a unique language and does not collapse. And always the salt, because this is the University of Aveiro, the University of the people, alchemists of water, earth, and air.
Morro de amor pelas águas da ria. Esta espuma de dor, eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor nesta rede que teço, e é no sal do suor que eu aconteço.
Air, water, they come together in the sea-salted lagoon, rocked by the tides and mixed by skilled miners, alchemists of salt. Just as the white crystal is the pillar and cornerstone of Aveiro, teaching, cooperation and innovation are the pillars of its academy. The University of Aveiro surged and flooded into the region, the country, and the world. Interdisciplinary research is also the foundation of the University of Aveiro, in which scientists from many fields share and grow on a campus that brings people together, forming a better future. The University of Aveiro, an innovative pioneer of knowledge sharing with its 90 nationalities, is a gathering point of people from all over the world, a space of different cultures, languages, and worldwide passions. A Tower of Babel, but one that retains a unique language and does not collapse. And always the salt, because this is the University of Aveiro, the University of the people, alchemists of water, earth, and air.
Morro de amor pelas águas da ria. Esta espuma de dor, eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor nesta rede que teço, e é no sal do suor que eu aconteço.
Air, water, they come together in the sea-salted lagoon, rocked by the tides and mixed by skilled miners, alchemists of salt. Just as the white crystal is the pillar and cornerstone of Aveiro, teaching, cooperation and innovation are the pillars of its academy. The University of Aveiro surged and flooded into the region, the country, and the world. Interdisciplinary research is also the foundation of the University of Aveiro, in which scientists from many fields share and grow on a campus that brings people together, forming a better future. The University of Aveiro, an innovative pioneer of knowledge sharing with its 90 nationalities, is a gathering point of people from all over the world, a space of different cultures, languages, and worldwide passions. A Tower of Babel, but one that retains a unique language and does not collapse. And always the salt, because this is the University of Aveiro, the university of the people, alchemists of water, earth, and air.
Morro de amor pelas águas da ria. Esta espuma de dor, eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor nesta rede que teço, e é no sal do suor que eu aconteço.
Air, water, they come together in the sea-salted lagoon, rocked by the tides and mixed by skilled miners, alchemists of salt. Just as the white crystal is the pillar and cornerstone of Aveiro, teaching, cooperation and innovation are the pillars of its academy. The University of Aveiro surged and flooded into the region, the country, and the world. Interdisciplinary research is also the foundation of the University of Aveiro, in which scientists from many fields share and grow on a campus that brings people together, forming a better future. The University of Aveiro, an innovative pioneer of knowledge sharing with its 90 nationalities, is a gathering point of people from all over the world, a space of different cultures, languages, and worldwide passions. A Tower of Babel, but one that retains a unique language and does not collapse. and always the salt, because this is the University of Aveiro, the University of the people, alchemists of water, earth, and air.
Morro de amor pelas águas da ria. Esta espuma de dor, eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor nesta rede que teço, e é no sal do suor que eu aconteço.
Air, water, they come together in the sea-salted lagoon, rocked by the tides and mixed by skilled miners, alchemists of salt. Just as the white crystal is the pillar and cornerstone of Aveiro, teaching, cooperation and innovation are the pillars of its academy. The University of Aveiro surged and flooded into the region, the country, and the world. Interdisciplinary research is also the foundation of the University of Aveiro, in which scientists from many fields share and grow on a campus that brings people together, forming a better future. The University of Aveiro, an innovative pioneer of knowledge sharing with its 90 nationalities, is a gathering point of people from all over the world, a space of different cultures, languages, and worldwide passions. A Tower of Babel, but one that retains a unique language and does not collapse. And always the salt, because this is the University of Aveiro, the University of the people, alchemists of water, earth, and air.
Morro de amor pelas águas da ria. Esta espuma de dor, eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor nesta rede que teço, e é no sal do suor que eu aconteço.
Air, water, they come together in the sea-salted lagoon, rocked by the tides and mixed by skilled miners, alchemists of salt. Just as the white crystal is the pillar and cornerstone of Aveiro, teaching, cooperation and innovation are the pillars of its academy. The University of Aveiro surged and flooded into the region, the country, and the world. Interdisciplinary research is also the foundation of the University of Aveiro, in which scientists from many fields share and grow on a campus that brings people together, forming a better future. The University of Aveiro, an innovative pioneer of knowledge sharing with its 90 nationalities, is a gathering point of people from all over the world, a space of different cultures, languages, and worldwide passions. A Tower of Babel, but one that retains a unique language and does not collapse. And always the salt, because this is the University of Aveiro, the University of the people, alchemists of water, earth, and air.
Morro de amor pelas águas da ria. Esta espuma de dor, eu não sabia. Sou moliceiro do teu lodo fecundo. Sou a ria de Aveiro, o sal do mundo. Morro de amor nesta rede que teço, e é no sal do suor que eu aconteço.
Air, water, they come together in the sea-salted lagoon, rocked by the tides and mixed by skilled miners, alchemists of salt. Just as the white crystal is the pillar and cornerstone of Aveiro, teaching, cooperation and innovation are the pillars of its academy. The University of Aveiro surged and flooded into the region, the country, and the world. Interdisciplinary research is also the foundation of the University of Aveiro, in which scientists from many fields share and grow on a campus that brings people together, forming a better future. The University of Aveiro, an innovative pioneer of knowledge sharing with its 90 nationalities, is a gathering point of people from all over the world, a space of different cultures, languages, and worldwide passions. A Tower of Babel, but one that retains a unique language and does not collapse. And always the salt, because this is the University of Aveiro, the University of the people, alchemists of water, earth, and air.
Parecido, pero no así. No sé por qué. Es muy forzado.
Okay. Can we start now? Thank you. Well, welcome back, all of you. We are only 20 minutes late. Back again to the latest. In this second session, we'll have Cristina Fernandes from Loriza Research Center. We will have Artemi Serdá from the University of Valencia. And we will have, sorry, I jumped here one, João Pinha for the Institute for Nature Conservation and Forest from Portugal. We will focus this second part of the session on managing hydrological fire impacts, and I will call Cristina to come to here so that I can put her presentation working. Is this one?
Yeah. Hello, everybody. I am trying to summarize the work that we are carrying out in northwest Spain, facing the post-fire erosion. I am a researcher in the Loriza Forestry Research Center, that is a research center that belongs to the Galician government, a regional government in Spain. We are placed in an old facility from the end of the beginning of the 20th century. It's very nice. I invite all of you to visit it when you have time. And I work in the forest fire unit that we are researchers. We carry out research projects related with different aspects of the fire, preventive modeling and also restoration after forest fire. And we provide also assistance to the managers, to the forest managing section of the government in all the questions related with the restoration after fires. So we are provide them with technical and scientific support. We know we are very interested. This unit started at the end of the 70s, only because in northwest Spain forest fires is a very huge problem. We are in the last years reducing the number of fires, but we still have a problem with the area. Especially this graphic ended in 2017. That was, we have almost no fires in the last 2 summer seasons. But in the 2017, like in Portugal, only in 2 days, more than 50,000 hectares were burned. And because in northwest Spain, the forest fires are endemic, are systemic, and we have a combination of the 2 things. The problem when the fire is still burning and the post-fire risk. And you know, especially for that, you know, this is one of the biggest fires in the Pontevedra province in October. I think it is more than 60 kilometers long, and you see the villages near the burned area. This is something that is a common feature in this kind of landscape, and that's why this kind of risks are also important. And also, this is other, you can see different, the amount of soil erosion gathering during the first year after fire in different places in Galicia. As you can see, we can have almost nothing, and you can reach more than 50 tons per hectare year. These are the highest erosion rates measured in the Iberian Peninsula until the moment. We don't know, we never know. So, until the middle 2000 decade, all the people thought that only because we have a mild climate, we have rain, and we have also a very mild temperature, only waiting for the vegetation to grow, we don't have erosion problems. Everybody think in Spain that the erosion problems are in the south or in the eastern Spain, but the reality is that it's in the north corner of Spain. And that's why even we have a quite good vegetation regrowth, is not enough to avoid soil losses, because more than 80% of the soil losses after fire during the first year happen in the first 3 months after fire. So soil losses are concentrated in the first 6 months, 3 months after fire, more than 80% of the total losses. So that is why after the fire season of 2006, we started to deal the post-fire activities with the hydro emergency stabilization. That until this moment was something new in Spain and in Galicia. Until that moment, we understand the restoration activities, trying to follow the vegetation regularity. And now we focus our attention in this part of this graphic, trying to avoid the sediment movement. And you have to make all the actions in the first year after fire. So you have to be prepared. No? And especially in 2013, we wrote a protocol that is now commonly used by the Forest Administration. It's a way to act in a I can't find the forma pautada. Systematic way. Sorry, but I can't find the proper word. And this protocol is consisting following a yeah.
Huh? Okay, here it is. Just press this one. Okay.
I'm scared of.
Oh, no, it's okay. Or you just go here into this one.
To follow some steps. I will focus my attention in only 2 of them because I have no time to enter in all. But for us, the most important part of this protocol is this, the fire severity assessment. Because fire severity is the key point for all the post-fire activities evaluation. And it's a key fire regime parameter, but it also is the way to prioritize the post-fire emergency activities. We make a fire severity assessment in 2 levels, at soil, at vegetation level, and soil level, because the fire is never homogeneous. You have a lot of different fire severities interspersed in the middle of, and also you have different types of vegetation in many times in a short space. So the picture you have after the fire is quite heterogeneous. And we know that we have to combine these 2 aspects, because you have only in terms of vegetation 2 types of risk when you have a prone fire, or another type of risk if you have moderate to low fire severity fire. In the case of the soil, we have a particular classification that we developed in the group. You know, if you work with something related with this topic, most of the fire severity classifications have 3 degrees, but we found that this classification in the beginning with 5 levels and now with 6 fits better with our situation. How we made the fire severity assessment? We use all the things technical or technological advances that we can. If we are lucky, we can fly over the burn area to situate more or less where the worst part of the fire may be. This is a wildfire in the Coruña coast. This is a place with a lot of people living in the surroundings and very touristic too. And we also use satellite. The question with the use of satellite is that they only work in a more or less reliable form with the vegetation, but you can use for the soil, or at least our experience is not good with them. And we have to, we spend some time doing soil burn severity surveys in the field. We focus our surveys only in the places where we have shrubs, so there is no possibility to have a needle cast, or in places with trees that suffer a crown fire. Only because we measured before that in the places where you have this kind of cover, the level of erosion is almost 0. No? So we don't have no need to care in this kind of places. And why we use these 5, 6 levels of soil burn severity? Why we prefer to use this? Because we found that they are related with the alteration of a lot of soil properties. Some of them are soil organic carbon, the soil aggregate stability, soil water repellency, and for us the most important, with soil losses. You see, and we also develop a kind of empirical model to predict soil losses after fire. That is the model we are using to prioritize where we have to do some works or not. This fire severity evaluation and the location of these areas in a map, looking to if some population are in danger or water reservoirs or whatever, allow us to rank the places that are going to be treated, like in this example. And you see different places that we know that they are in danger of heavy soil losses, that they are ranked in numbers of preference. At the end of the... And now that we decided where is the problem, the question is what we can do to reduce the soil losses. So the other thing that we made in the group during the last 15 years is to try to check some different treatments to reduce the soil losses. At the beginning of our activity, all the things we we made were experimental. We made a set of experiments in burned areas trying to convince to the forest managers of our results, because the forestry people are used to make barriers, because it's something that they learn in the school. So it's not easy to change the mind. At the end, I think that we now can, or at least they trust in our work, and they are now mulching believers. But it was not so easy at the beginning. So we checked for at least 5, 6, until 10 years different treatments. You know, I will list quickly because it's not in different situations, comparing, especially our aim was compare mulch cover with other things, typical things that everybody thinks that will work, like seeding, barriers, trying to demonstrate that only when you cover the soil you can have good results in terms of cellulose reduction. So you can see that all the results are in the same way. And at the end, the Galician government started to do things in a landscape level, in an operational level. This is after the fire in 2010. These were strips manually made, like this, like this. And we also now can use the mulching dropped through the helicopter. That was the first place in Europe that I think we are the first and almost the unique doing that. It was made the first time in 2010 and is something now normal after fire in Galicia, especially until 2013. That is something that even people in the villages ask for mulching after fire. So I think at the end we made. And you can see after the helicopter mulching how the cover is in different places. And also my unit after treatments is monitoring if the treatments work or not. So we have a set of monitoring plots at least in all the important files, because it's not easy to attend in many cases all of them. But we have in this moment a network of around 100, I think more or less 100 erosion plots like this, so distributed in the whole region. And okay, we have some results about early mulching now that are more or less in the same level as we experimented before in our experiments. This is in an operational way, and also we can say that the early mulching works more or less as the needle cast. So I think it's important to say, and also with no consequences for the natural regeneration of the vegetation or no alteration of the soil properties. And we also are interested in the guidance of the forestry activities and the combination of the mulching treatments with the salvage logging. Because in the northwest Spain, like in Portugal, this is an important activity. Because these forests are planted to be cut. So it's not the same philosophy if the trees are they are in a natural area or something like that. This is another kind of philosophy. So it's important to also to combine mulches with the cutting activities, or even the managing of these kind of juvenile stands with another kind of mulches that are provided directly when you masticate the trees. We also, the results depend on the feasibility, if you have enough slash or not. And for us, I think all this work is at least until this moment is more or less a success, because we are working with the managers with more or less without no problems, because we have a good connection. We think that our soil bank severity classification is good and is also operational. And we know that the mulching with any kind of material is the only way to reduce soil losses after fire, because only the cover the soil is the solution to reduce for fire erosion and all the consequences, all the pollutants, all the movement of. And if you want to, some of the results are gathered in this book that can be downloaded from our website. Thank you for.
For his presentation from National Institute for Forestry Conservation. Oh my God, I don't. Okay, sorry if I'm mistaken. It's hard to say CNF in English, but well, here you have. You press this one here to point. If you press up, you go back to the same thing.
Good afternoon. My first words is to thank the invitation to be here. It's good to learn much more things and to share some information with our colleagues. I apologize in advance for my English, which is not very good. I hope you can understand. If anything is not understood, then we can afterwards. My idea was to make some general views on the Portuguese fire problem. We are mostly an Atlantic country. Our main problem regarding post-fire effects, it's not even in the mainland. It's our worst case is Madeira, where we can find the worst effects of fires. And historically, they have suffered a lot with fires which are prevalent also in the landscape. But because legislation is different there, it's another country, I will speak mainly on the mainland. And we have a very diverse country. We are a very diverse country. We have different landscapes in the northern parts, in the southern parts, and also in the interior and in the coastal areas. So regarding post-fire treatments, we should have different approaches because the forest types and several other ecosystem features, they are quite different when we're talking about different regions.
Yeah.
And the basics, which is rainfall. We have some very wet areas in the northern part of the country, mainly those areas that are next to Galicia also. So even though we don't have a water scarcity problem, we still have, even in the northern areas, 1 or 2 or 3 years or 3 months very dry in summer. So we will always have a fire problem. And so also our aquatic systems, they are different in different regions. This is the classification of the water courses regarding to the type of fish that we can find there. In the northern part of the country, in the mountain areas and in the more wet areas, rivers are good for salmonids, which are trouts and salmons typical from cold areas and typical from mountain rivers. In the southern parts, waters are hotter, they are not so cold, and different kinds of fish and different kinds of aquatic ecosystems can be found. And also, regarding forest cover, we are also a very diverse country. Even though the main forest species nowadays is the Tasmanian bullgum, eucalyptus, most of our forest species are native. And in the south, we can find cork oak and alm oak stands, which are typical oak savannas, very open and with low cover, typically. And in the northern parts, in the western coastal areas in the north, we can find typical forest production areas with eucalyptus and with pines quite similar to those that Christina also showed in her presentation. I forgot to say that 97% of the forest is private or local communities managed. The state only manages 3% of the forest. And as in Galicia and other parts of southern Europe, forests have been growing since the 19th century. And even with an high fire incidence, we can see that it's stabilized at about 40% of the national territory. And there was a little change in the forest composition. We just started using eucalyptus after the Second World War, at the expenses of mostly pine woods, which are the two main wood production forest systems. But another important feature was that the biomass collection that was typically made by rural people decreased a lot. That is an indicator from the state-managed forests, national forests and communal forests, and we can see that the uptake of biomass has declined very, very, very fast since the 60s and since the 70s. So the species that are our typical species may be the same, but the internal arrangement of the forests are quite different. There are much more full continuity inside forests. Okay? This is a graphic very similar to Christina, since we have statistics that are official, and we can see that after some good results, when we took some measures after the 2003 and 2005 fires, we had another very bad season. It was 2017, which unlocked a new set of reforms that we are still defining and putting in place right now. Those were our objectives regarding rural fire management. This is the total burned area. We just for a moment we were under that level, but 2017 and all the years, all the 10 years periods, it's right. It's very difficult to keep with that objective. So we just have to live with fire, and fire was and is a permanent feature of the landscape. It's our ecosystems were created and they are used to fire. This is the number of fires that each point, the number of times that each point burned in the last 45 years. So you can see that only 70% of the landscape didn't burn once. 30% of our territory burned at least once. In some points, it was burned 17 times, okay, in 45 years. So it's a 3-year rotation, 3-year return period of fires. That's a problem that we face not in all the territory, but in some parts of the territory. And in those parts, we are fighting wildfires, but we are at the same time promoting prescribed fires. So much of the research that we have seen here today, it will be quite useful not only post-fire treatments, but also to plan prescribed fires, because it's a full management technique that we are now trying to expand and try to simulate what our ancient rural area people have done in the past, because they burned a lot. They use fire commonly. We lost that expertise, and we must regain that use. So everything what has to do with protecting soils after prescribed fires, or fires that rural people still are doing for grazing purposes, for example, it's good for forest planning and nature conservation planning. And we have fires, and we will have, as I told you, we will have fires because we can build up fuels very quickly. We are in a part of Europe, like southern Galicia. We are the red ones here, and ecosystems will always build up fuels. It may be not oaks or pine trees or eucalyptus. It can be shrubs. It can be other types of fuels, but there will be always something to burn. And it's a problem that it has to do not with the people or not with the management. If we superimpose the western parts of North America, in Europe, the states of the United States and the provinces of Canada, you'll see that the deadliest fires, it's exactly in the same points. Our deadliest fires in 2003 and 2017, it's in the exact points of the Californian fires that were lethal in 2017, 2018. So we are a poor country. The United States and California, it's probably the most rich state in the United States, but the problem is the same. And the social cost of fires, they are rising, not only regarding post-fire treatments, but also all we must do to prepare the landscape and prepare the ecosystems to fire. And we cannot afford that. So we have a system of post-fire restoration, which is not so well developed as in Galicia, and I will tell you why. The first step is damage assessment. We have here some problems, mainly regarding with fire severity evaluation and validation in the field. We can do quite quickly fire severity assessment, but not validated in the terrain. So that is a lack of knowledge that we have. Then the first step is emergency stabilization. We have seen a lot of examples here. Then rehabilitation. In Portugal is quite important because since those are private forest areas, we must do all we can so that they can remain productive, so that investments that the private owners do there, they can do that again. They don't lose interest in forest management. We cannot have abandoned forest areas because they will be danger areas. And then the long-term restoration, which it's quite important, and it's one of our most difficult problems, because mainly of the forest regime and land tenure regime. There are a lot of agencies that deal with forest restoration. I will just say that those agencies that are responsible for coordination, they are not exactly the same with the money. Where most of the money and the appropriations come from agricultural policy. I don't know if in Galicia it's the same.
It is more or less, it depends.
But in Portugal still is, and those kind of funds are quite difficult to mobilize. They have problems regarding legality, and people don't use, and we take too much time using that money. For example, for this period in the agricultural common policy money, until today we just spent 20% of what we planned to spend. After the 1270 fires, after 1 year we just had spent 5% of what we planned to do, because it's quite difficult. There is a lot of bureaucracy. Most of the land is private owned, and the private owners don't want to invest money, not knowing that they will have the money back. And as I told, private owners are the main recipients of the investments. And water protection, that is this blue area, it's about 20% of the investment in post-restoration efforts. Just one example, I will give the restoration project that we had in our largest national forest, which is a coastal one. This is two years after the fire, and you can see all this green is acacia. Our colleague already presented us this morning with the acacia problem. So all these, they grow very quickly. If we do nothing, we will have a stand just of acacia. And after the fires, we did some work with the rivers, with some streams. Fortunately, we had some survey points of the water directive, and we could see what was the biological conditions before the fire and after the fire. And then after the fire, we set up a scientific commission from people from several universities and research laboratories, and we studied the water. Also, one of the working groups was related to water and water ecosystems, and it was interesting, the results. We had the preliminary results, and the native fish and the native amphibians, they were well with fire, no problem. Even the native fishes, which we can find here, 4 native species, they grew after the fire, and the only one that was declining their numbers were the one that our colleague showed, the gambusia, and it's not a native one. So it's interesting because the natives, the fire was not a problem for the natives. They are used to fires, but the non-native, it was the most affected. And in several places we have some special techniques. This is over a dam, an aerial seeding project, and in other places the forest roads network protection. That is a serious problem in Portugal. Also, I think in Galicia, because we have a very, very dense forest road networks. If we don't have the forest roads, the stands don't have an economic value. So it's important for forest management to have forest roads, but they are a risk to erosion control. And the main challenges, just to start finishing, we must have more information. Much of this information is quite interesting to us. And this is just an example. This dam is up in the watershed that we've seen this morning, Castelo de Bode. It's another large dam, and all this area burned in 2017. So this is about 1 year ago. This is the place where many of the people died in the June fires, and this is already ready to burn again. Just 3 years. And you see, it's a landscape problem. It's not a problem from this forest or that people, and this is really a task that we have ahead. So one of our main objectives is to have the emergency stabilization actions done timely. That's our main problem. We don't have our human resources to do that by ourselves. And we are now trying to regain that capability, ensure the landscape level management, which is essential to our country. And we are now, as I'm speaking now, there are several groups in Lisbon working with new legislation that will be enforced this summer already. And we must, and I'm sure that we change much of these problems in the next few months. So thank you.
Thank you, John. That was a wonderful overview of Portuguese state of the art. I should now call Artemi for his presentation. We are a little bit later again. Here I have. Can be this one?
Yeah, but you have connection. I wanted to go to the cost
to the Firelinks website.
And also to the one of the congressmen.
Okay.
To another people that they can.
Let me just shut down all my social media pages before. You can have my calendar, it's okay. And my scope.
It's Firelinks. And the other is Fire Congress. Fire Congress. I don't know if you will catch me.
No, but if not, I'll do something else here.
Should be Fire Congress.
Like this?
Yeah, should be. It's fire in their system.
Okay. Did you catch? It's here slowly, but on the way.
No, it's perfect. No, I don't want to go to especially for Firelinks. The people will know that this.
I try to
15 minutes? Okay. I only have 15 minutes and I have 3 main issues to talk about. The first one is the Firelinks. Remember that we have a web page that is used to coordinate all the people that is involved. We are almost 500 people now registered, and we suppose that will be more. You can, this is the Congress one. Sorry. This is Firelinks. Then here you can see who we are. I will explain you later better who is the people involved. This computer is too good for me. This is the core group, the people that is managing
I can go there.
Go. I can eat slowly, but it's very difficult.
Yes, I know. It's a very sensitive laptop.
Okay.
Okay.
Then you can ask anybody from the core group anything you need. Stefan is the vice chair. Everybody knows Stefan well. Nieves Fernandez is in charge of the working group 1, is about fire dynamics. Lea is in soils, and in biota. Irina is in soils. Jo is in water and sediments. And Nuria is the mostly in the social or dissemination, in the social part of the forest fires. And then the STMS, you know, is the scientific missions. Then you can go to another place. Anna Brooks is in charge, and Yanis is who is in charge of the dissemination and running the web page. Thomas Smith is the person who is in charge to connect with the young people, the young scientists. And Jesus is the grant holder or the manager, we can say. Okay. He is the one that should reply you if you need anything. And well, here you have many other things. For example, if you want that your publication will be visible, you can tell us, and we can also we have a blog. Should be updated, a blog in which you have the every month we have a post, and I invite all of you to send your post, and we will publish. For example, all the interesting ideas and information you gave to us, Joao or Cristina. If you want to make a 1,000 words and some pictures, it's wonderful because it will reach a lot of people. Then what we are trying to do is to be active and to be visible and to connect with the stakeholders. If in the next 4 years, that is the action will run, we are not brave enough and efficient enough to connect with the stakeholders, our work will be not successful. We already know each other. Most of the scientists, we know what the other do because we have the publication system, the congresses is very efficient. And if you want to know what the other colleagues are doing, it's not so difficult. But the problem is how to connect and interact with the stakeholders. The stakeholders, they have a lot of knowledge. And we are not using this knowledge. And we have also very good knowledge that they don't know. Then this interaction is what I think will be very important. Connected to that, we are promoting that there will be more activities about forest fires. Remember that in the European Union there were no calls, scientific calls for funding about forest fire for many years. We are trying to push, to make a lobby, to push the European Union to at least to open new calls for that. You know that this is a traditional problem of the European Union is that who is pushing more is getting more. Okay, and now it's very
planning. That's okay.
You have a very sensitive.
Yes.
My computer is 5 years old, and then within all these, all these activities, last year I decided that I need to be an example for that. Then what I did is I applied for a project in the last call, and in every call that we will have, I will try to be the leader, or somebody will be the leader, but within the Firelinks, in order that everybody that is involved will have the chance to get some funding. Okay, and also one example is that I go to organize this congress. I expect that this congress will be every year or every 2 years or every 3 years will come again, in the way that to show what the people is doing. And in this congress there will be 3 days of talks, but 1 day in the field. And we are going to put the congress nearby the 2 meetings of Firelinks. One like we are having here, there will be working group 1, which is about fire dynamics. We have the meeting straight on after the meeting. And the MC meeting will be 2 days before the meeting. Then the people can come for the meeting, for the MC meeting or for the working group 1 meeting, and then can attend or not to the Congress. But in total, there will be 4 days of excursions. In total, it will be a long meeting, okay? Excursions, which means to talk with people and to talk to the people that is involved in the forest fire management. Firefighters, land managers, owners of the land, and so on. Okay. This is not mine, eh?
No, this one.
No. But we need to open the other one, which is Israel. Also, this I can use this, but I will open this. Thanks for the assistance. Thanks for the assistance.
It's no problem. Just want to make sure you keep the 15 minutes.
Don't worry, just tell me I cut really fast.
I'm going to see if it's opening. I don't know if it's opening.
It will take, don't worry. Now we'll talk about this first.
Okay.
Well, this is just that you will have a rough idea about what is Firelinks. Firelinks was applied 2 years ago, first by Saskia Kestra and me, and we did not get success. Then this is quite usual that it will be difficult to get a success. Then later on, Stefan and me, we polished the proposal and we submitted, and we were lucky. It's very, very difficult to get 100%. There are many people applying and very few getting. And then the idea was to accelerate the exchange of knowledge between different parts of the society, not only scientists, also with policymakers. And this is all the plan that we have for the Firelinks. This is the people that we're telling you who we are. And then the important thing is that we will connect with the stakeholders. Okay. Then, if you have any question or any suggestion about how to manage, you are invited to contact us. And because still we have 3 years, we already planned year 2 with meetings. But year 3, year 4 is not planned, and there are many options to be involved. There are short scientific missions that you can apply, and then you can get some money to visit somebody and work with them. There are meetings that we also organize. We can help you in publications. All these activities, I think, is work that you will apply. And now I will tell you what we are doing in Valencia, because this was the idea of my talk, but also as a Firelinks chair, I think it was good that I will inform you about this. About how to be reimbursed in Firelinks, if you need any information, Jesus is who is in charge of that, but I can explain you later. But most of you already know how to manage with this. Okay, some of the things that we are doing in Valencia is this. After the forest fire, one of the things that we are interested is to come back to our old topic, which is infiltration. How the infiltration change. For example, in areas where you have a lot of litter afterwards, after the forest fire. And then what we are using is ring infiltrometers and mini disc infiltrometers. Also, we are using one method that the colleagues from France, they know very well, the best. I learned this method with Simone Di Prima and Lorena Sabater, and then what we are doing is going further, not only with one ring, because we try to do it 3-dimensional. Then we use 10 rings, and now we are trying to use 10 by 10, 100, which is a lot of work, but also will give you a dimension of how the process is taking place. This is how we work. In this case, for example, the experiment is with and without ash, how the ash affected. Okay, water repellency, which is a topic that all of you already know. Also, we are applying this in a small plots, the ones that we burn later on, and we use the ash to measure the erosion. We have done this in normal plots, but we are trying to apply for also in this project that the measurements are very accurate. Also because we can measure the splash in this project, and the splash is one of the lost topics in after a forest fire. We used to talk about after a forest fire there is a lot of erosion, just with the idea that the soil is moving to another place, but sometimes what I have seen is that the soil is moving from one place to another. It's not really going out of the watershed, it's mainly a redistribution. Okay? This is, for example, the runoff coefficient and the effect of ash. If you have a lot of ash, you don't have a runoff until the ash is lost. Okay, these are other parameters that we measure in comparison to the ash cover. For example, the soil erosion, if you have a lot of ash, more than 60% is difficult that there will be runoff. But also, if there is runoff, if you have a lot of ash, you have a lot of sediments that move. Okay, because the ice change the density of the water, and then it can move other particles that were not allowed. Well, another question that we found is that after the forest fires, we found that there is a huge opportunity to measure trail erosion. You know that some people is crazy and they not only walk in the mountains, they also bike, they also run, and even they go with motorbikes. And they are producing erosion everywhere. Once you don't have the vegetation after a forest fire, you can use drones, for example, to measure this. Not only direct measurements in the field, also with drones. Then we have done some measurements with different methods, direct measurements like these ones. And I can tell you that some of these trails, they move more sediments than the whole slope. Usually the slopes are quite stable, with they have vegetation, but the trails are, in some places after 3 or 4 years you have 10 centimeters of soil lost. Okay, well, these are comparison of different methods that we are using. Well, this is unbelievable because we use it 3 different methods. One is with 2 telephones to make a survey of the surface of the topography. One is with a drone, and one is just going there with a ruler and a tape, which is cost around €3, all the equipment. The drone costs 12,000 euros. And then the results are the same. Just that you need more time in the field, okay? I pass this. We have some plots, we are following these some plots, and we are testing the effect of different managements. We are all very worried about what to do after a forest fire. My impression, my opinion after many years is that one option, a very good option, very clever option, is do nothing in some of our countries. Yeah, because we have ecosystems, especially in the Mediterranean, that are adapted to forest fires. And then many part of the society, especially the one that don't live in the countryside, they think that is a big damage. And then what I have done in the last 2 years is to bring people after a forest fire. I bring people that come to talk about the forest fire. They come very depressed. But when they walk 3 months after a forest fire and they see that the vegetation is recovering, it's not like that. Okay, I finished with this graph. Okay, I have more, but it's not necessary. This is an interview I did to people in the district of La Canal de Navarrés, which is an area that had the largest forest fire we never had, at least in the last century. It was 50,000 hectares in 3 days were burned in 1979. And then I went to this district and I did interviews to people. And then I was asking questions about many other things, not only fire perception. But this is about which is the perception. 0 is very negative, the fire is very negative, and 10 is, well, no problem, fire is part of nature. Okay? And this is the age of the people that replied. You see, the people that go to the school and go to the high school, okay, they think that the fires are very bad. And the trend is when you are older and older, you see that the fire is not so bad. Why? Because these are farmers, people that have been seen, they already have seen fires forever. Okay, and then my impression is that our students, they see fire as a big problem. like the climate change or global warming or the problem with deforestation in the Amazons. In fact, they know very little about what is going on around the country, but they know a lot about what is going in Antarctica or in the rainforest. And I think this is one of the topics that we as a scientists we need to change. That the citizens will come with us to the field, and they will see what we are doing, and they will understand that fire is also, more than an environmental problem, is also a part of nature. Okay, that's all.
Thank you, Artemio. I will now invite the presenters to come here, João Pedro too, maybe you have a place here if you want to. I think it would be important because he's ahead of the working group. I'll be standing, it's okay, not a problem. No, come on. The discussion was very reduced previously, so I think that we can take a little bit of advantage of all the topics today that were taken, were talked previously, and also a little bit following what Artemio told about transmitting a little bit our knowledge to the society, even if it's just the general population or stakeholders having a bigger involvement. It's an important thing. So first of all, I would like to ask if anybody has a question at hand. Okay, we have two questions. First, Turgay, please, can you ask your question?
Thank you very much. My question is about mulching method. Just my curiosity, mine is longer. My question is about how did you provide homogeneity, distribution of mulching by helicopter?
You have to that's why the first experience that I did in 2010 was to train the pilots to doing that. Because the question of the altitude of flight and also depends on the people. But you have to train first. It depends also in the place. And also depends on the moisture of the straw. If it is more or less dry, the straw bales open more easily than if the straw is wet. So it's a combination. I have no one recipe. It's a combination of the ability of the people in the helicopter, some of training, the height and it's the same if you are in the firefighting site with the water.
Did you measure?
It's the same system.
When you try to put down fires, they also practice a little bit. They also practice all the pilots before.
Yeah, they are the same pilots. They are the same because in Galicia the helicopters are not public. We have some kind of contract for all the things related with the fire, and they are the same people in the firefighting. And for them, it's also a very good experience not to see only the fire like something that is bad, but also trying to recover. They feel that they are doing something more. Yeah. So it's a very nice experience because we have contact with them, and for them it's also an experience. Imagine it's I don't know, but almost 1,000 kilos of straw in a month. So you have to do.
Okay. So next question.
It's just that something to this. Do you know the application rate at the end of the straw boats or helicopters? Application rate.
When we use helicopters, we usually use by hand 2.5 tons per hectare. When we use helicopters, we try to use 3.5 because the distribution obviously is not the same. But it's not possible to reach some places on foot or by car. So it's the only, and also it's more rapid because you can. The question with the helicopters at the end of the season, like in October, is that the available time for flying is not the same than in summer. So it's also a limitation because they only can be in the air during the day. Yeah.
But the application should be not very high, the doses, because if you cover the whole surface, you avoid the germination of the
Yeah, they check for that.
we also check the germination and also the soil. And only in, we don't, only in very few cases when the straw is wet and you can have a pile of straw like this, you can have problems, but this is not the normal.
In Valencia we have some places where after the forest fire they chop it all the Aleppo pines and they put like 20 centimeters of moss.
Yeah, this is not the case.
And it's not, they last, the decomposition can last for decades.
Yeah.
Then they
So
change
the
the
days of
organization.
straw, and we avoid this kind of thing. We measure a lot of this, and also the rate. In most of the cases, you can find the straw at the end of the second year. You can know it's impossible to see a straw, and the average depth is around 2-3 centimeters. So, and you think that in our case we have a lot of resplorters, and the vegetation dynamics in the north is not the same. Like
No,
because we have,
resplorters.
and also if we think in pine, we also measure the tree because for us it's very important to rely on the natural regeneration because it's not possible to plant.
Some of the experiments what I have done in the last 2 years in the laboratory with a big rifle simulator, they go in the direction to decide which is the pattern of the straw. You can apply, let's say, 250 grains per square meter, but you can apply this in one uneven or in different patterns. I'm using Nacha works on that. And there are patterns that are more efficient. To stop erosion, you don't really need to cover everything. If you cover 25% of the land, you reduce a lot the soil erosion.
25% in our case is not enough. I am sure of that. We need at least as 70% to be effective.
But when you say
the same.
Yeah.
But when you say efficient, is to reduce almost to zero. Is that
Yeah, but we are still trying to improve our system.
Yeah.
So for us, the question is not finished because we are aware that we can improve in many terms. But now, especially, it was very difficult to address the fire season of 2017 because it was at the end of October. For us, and we were able to work and it's not easy to, even for us that we are also part of the government, of the regional, even for us it's not easy to work with the management section because they see the things not in the same way. And we were able to work together and to make, I think, not a bad job, but it's far from being perfect.
Yes. Let's go to another question. I see Martina behind it.
My question goes to João Pio, but if any of you feel comfortable to add something, it's a focus on the general society and where are we missing. And I will just tell very briefly the episode that is happening now in my hometown that I just read on Facebook with persons that I know, which in the mountains the municipality are promoting the prescribed fires to avoid fires because the mountain there, when it's a bushland, when it burns, usually burns the whole mountain because there's no valleys at risk there and the firemen, there's not that much road, so they let it burn all. So this year they are promoting prescribed fires to try to avoid it or reduce the risk. And many of colleagues, my high school colleagues and many people that are now against the prescribed fires, which I know because in my job I learned that they are good and they can be used in the proper way. But where are we missing doing wrong information? Because if we develop this in universities and we say in our scientific world we say it's good and we see the advantages and the disadvantages, but then the information doesn't go to the general public and they see fire, but fire is always bad. So picking up in what Artemio was arguing, like we are failing somewhere, and my question goes to you because you're we're more related with our science and our society, but what are we failing in this kind of pushing the society and then to understand this kind of problem?
Probably we are the responsibles for that. For example, the public campaigns on forest fire awareness, the message sometimes is not very good. For example, for many years in Portugal, as in the United States, the slogan was, I will tell in Portuguese, Portugal sem fogos depende de todos. Portugal without fires depends on you. And we don't want a country without fires. We want a country without deadly fires, without large fires. And this kind of message was wrongly, in my opinion, transmitted for many years. And all those years to revert that will take the same amount of years. Okay? And this was a problem in the United States typically with the Smokey Bear. The message was wrong for decades, and we are now facing that problem. We changed the message after 2017.
Good fires.
Yes, there are good fires. We must live with fire. Fires will come someday in some parts of the country. What we don't want is destructive fires. We don't want deadly fires. That is the message. And then you can do something to prevent the damage that fires can. When we were discussing this.
Yeah, it's the same for us in the north. It's also part of our culture because we use the fire as an agricultural tool in many terms. So it depends. I think that if you are living in an urban area, you see the fire a different way than if you live in a small village, to say before. And we need to explain that, and not all the fires are catastrophic. That's why I try to insist in the fire severity evaluation, because this is the key point of this. You can have almost no effect after a fire, or you can have a very something that is catastrophic, like the video you show us. But in most of the fires are not so bad, are low or moderate severity. Only one or two in...
For example, we can lower the number of fires because in Portugal, 98% of the fires are human set, accidentally or intentionally. But in some years, we will have fires from thunderstorms. And in 2003, about 25 to 30% of the burned area was because of thunderstorms, and that we cannot, like in some parts of Spain also, in eastern part, or the United States or Australia. So we can prevent people starting the fire, but we will not prevent some dry season to have severe problems with fire. So we must always change the landscape and prepare people to that.
John, you had a question too before, or you don't remember anymore?
Yeah, I do. Christina,
After
you consider using pine needle as a method to protect the soil, not the needle cast that naturally falls after fire. Because I'm asking this because in the Canary Islands, that's an economic activity, so we collect, well, some people collect the pine needles
honestly, it works. We are not, we use the agricultural straw not for the question that is easy to obtain, and you cover with less. So we have no other.
Straw is a wonderful material because many reasons. One is that is the cost, the original cost of the straw is zero. The cost is to package and transport. Then if you will need to package pine needle, it will be more expensive. And also the good thing of the straw, in my opinion, is that after 1 year it decomposes, and then you don't see the effect. Already the vegetation is recovering. Then the first year, which is the key point after forest fire, you protect with
the question is for us, all these financial issues are activated after the fire. So we have all these things working. If we have no fires, we have no money. So we have no. The question is, the difference with Portugal is that we can activate money when an emergency happens. And we are more or less efficient to start. But the idea, because you need to store this in some place, and at this moment, no. The question with the Canary Islands, for us, is very difficult to to go there. So I suppose that's the main reason.
Question, Maria, please.
So, to add to the conversation, the prior conversation that we have about the prevention of that, what happens in Portugal and in Spain, since we have two representative countries, what do these countries do about the adaptation of forests to climate change? Because right now we're talking about how we prevent or mitigate the impact of forest fire. What do you do about adaptation of forests to the climate change? You just mentioned that in the future the most fires will be caused by thunderstorms. So because this is something we need to learn. Everybody talks in the European Union about adaptation, climate change, blah blah blah. So what do we do for the forest?
It's a difficult answer. Nowadays,
do you do something?
It's a difficult answer because, as I told, 98% of the forest it's not state managed or not state owned. So we must talk always with the people, which is.
Okay.
And you cannot make investments that are ruining for you. And forest management in most countries, it's not how can I say it, profitable.
Yes.
A profitable activity. It's very difficult to be profitable. Luckily, Portugal has a lot of rain, has 3 forest species which are quite productive, which is cork oak, maritime pine, and eucalyptus. So private owners are interested in investing in those species. The others, it's more or less difficult to convince them to manage their own lands. In other way, our most hot and dry region, it's where we have no fires, which is Alentejo in the southern part of the country. And it was the region where in 200 years ago, it was the worst region for fires. It burned every year. But nowadays it doesn't burn, just because of the type of land use that we have there. Because it's profitable to make agriculture, because nowadays we have water, we didn't have in those times. So it's a huge problem, and it's a huge problem with 6 million hectares.
So you don't do anything, but you would be forced to do something.
No, we must do everything so that fires that will happen, we will be prepared for them. We will restore forests to their prior to fire capability of production. That is our task. Okay? All those species that we have now, they are fire adapted. Cork oak, it's quite a fire adapted species. Cork is to protect and insulate the tree from fire. Okay? Eucalyptus, it's a sprouter and it's well adapted to fire-prone areas. Maritime pine, if we have the rotational fire is large enough, it grows. It's good, no problem. So we can take fire and put it in our silvicultural management systems, and we can live with it. Okay, that's our main task. Not necessarily to change landscape, because we are not able to do that. We don't have
So the reply is like living with it, better living with it than actually trying to change the landscape to prevent it.
And post-fire restoration, it's a critical issue, because we can, if we have success on that, we can restore the production, for example, production capability of the stands. So we can keep the forest owners with forest management investments. That's our main
Just
focus.
a small thing.
Yeah, you want to super. Yes,
this climate, this optimal climate that they describe that we have for fires, with a lot of primary production, fruit production will tend to move north. Also, so maybe the problem will go a little bit north of
It will be there, but you also.
I have one question there.
But just for Spain also. The climate
The question
adaptation.
was also for
the question
Maria was
for
asking
Spain.
for the climate
Yeah,
adaptation.
we are in the middle of a debate.
I will be very clear. In Spain, we have many words from the politicians, nothing done. The most advanced changes I have seen has been done by people that they built a community, people interested in their own land, and they are planting new trees from different species and making a forest that is more resilient. If you want to see this in the Congress, these will be the real important people of the Congress volunteer. They are associated that they are and they harvest all of them, including the oaks, which is proud. Everybody knows, except the companies that are working for 30 years on that. But and then a group of people they push a lot to the government to change that, and these companies are fired now.
Okay, you want to give another perspective, or
No,
from north to
my perspective is very close to Portugal, because we are the continuity of this in Spain. We are the upper part of Portugal. We now in Galicia are in a debate trying to change the law, taking into account also the climate change, because the question of 2017 was something that break the population, was something very strong. So we are trying to legislate in that term, but it's not easy because it's the same as here. The property is private, so it's not easy to change. And we are trying to make plans more in the landscape level, but it's not easy in a place where the mean average surface of its property is less than half of an hectare. So all the management is very difficult. It depends on the people, it depends on the place. Perhaps you have a community active and working well, and the other 2 kilometers far away is completely different. So our problem is the kind of property we have, and it's not easy.
Okay, one question for Marta, please.
I had something to add to that from the perspective of the
water
water sector.
Yes.
Because we are now studying the impacts and the effects on our water quality, because on the limit we have to adapt our water treatment plants to this scenario. For instance, if you compare, it's a different problem. In Alentejo, most of our reservoirs, we have algae blooms and cyanobacteria, and most of our water treatment plants in the Alentejo area are really very high-level plants with several treatment
activated when we have algae bloom problems that normally happen in the summer. So we just have this new treatment step during the summer period or during the time we have. It's the same for fire. If you have some kind of event and it becomes more frequent, we have to adapt our treatment plans, otherwise we don't have water withdrawal for people. This is another perspective because we are after you. After downstream. Yeah. This is a problem. It's something we have to.
Yes. Well, we can have continue this conversation over dinner later on. This was a very fruitful meeting. I would like to thank all of you for coming here. I think we can close the meeting for today. And tomorrow we'll go to the field and look a little bit on our and to all the people that are going to the dinner, it's scheduled for 8. João Pedro gave the Google Map link. You can follow it, not to get lost. If you need any assistance, please send me a message on WhatsApp or whatever. I'll be always looking to my phone if you need something. Any more messages?
Yeah, one message more, just to thank Joe and Diana for all the organization. We enjoyed it a lot to stay here. I suppose that you too now you're enjoying, but for weeks, for more than weeks, they were working very hard to organize this. Okay, say Diana. This is what Joe said, but I know that Joe was right. And then I have a small present for you, which is a cup from It's an t-shirt. This is the problem for the t-shirt. Come. This is what the organization is. Well, this is Joao. Do you think this is your size?
Like here on the shoulder.
Finance is good for you.
Yeah, it's perfect. Thank you. This is good for running. It's good.
It's really playable.
Not anymore. I'm thinking. Not anymore. Okay.
Okay.
That's another
Who wants to make a picture, please?
I have the phone here too.